All right, so last one in the group. We have something here called buoyant force. This is going to be important a little bit later on when we have a chapter that involves more types of forces and stuff about fluids. What we want to keep in mind here that the main concept and why we touch on this now, if an object is going to float, then we want to think about the net force as being zero. So that may not be immediately implied, but it's something we want to learn to think about. Um, the reason that it's going to be zero is that the object, whatever it is, has some kind of weight that's trying to come down, and then the fluid, presumably water, is pushing back up because of the water is being displaced. So for any action, there's an equal and opposite reaction. You push water out of the way, the water tries to push you out of the way, and that's where buoyant force comes from. So it's not a set formula all the time, at least not perfectly. It's really mostly just for things that float. But for our concept, and especially right here, we can say that buoyant force is equal to the weight of an object. Here's where you have to be really careful and not fall for the trap. Specifically, the weight of the object is what we're looking for. And remember, right now we have mass. Kilograms, we want to always remember kilograms are a measure of mass. If you're really paying attention, you should notice that it's asking for newtons. We don't have newtons. This is not the answer. So I don't know the weight of the object. But what we can do is we can take it a step further. We happen to know that weight can be found by taking mass times gravity. We have mass here. We're going to assume that we're on Earth where we know what gravity is, and now we can put this together. So still don't know the buoyant force, but hopefully I'm about to. From the question, the mass is 21.83 kilograms. Earth gravity, because that's all we have to go on right now, is 9.8 meters per second squared. Remember that the combination of kilograms and meters per second squared is the exact definition of newtons, so that's great, matches what we're looking for. Then now multiplying those together, looks like it'll give us about 213.93.